Welcome everybody to this call. Today I would like to introduce you to an innovative solution integrating two Spectrum storage products from IBM, and this integration provides significant advantages for the client. Before I really get started into that solution, I would like to give a short introduction to the two Spectrum storage products named Spectrum Protect, which is Tivoli Storage Manager, and Spectrum Scale, which is GPFS. And then I will show you why this integration of Spectrum Protect with Spectrum Scale makes sense and what the advantages are. Subsequently, I will discuss a few configuration options, how solutions can be designed and configured, and last but not least, I will highlight the key advantages and also the positioning of that solution. Spectrum Protect essentially is a comprehensive backup recovery suite for physical, virtual, and cloud environments. It can be deployed on-premise in physical or virtual environments, and also in hybrid environments. Spectrum Protect provides a comprehensive set of services, including incremental backups forever, deduplication everywhere, inline, compression, replication, snapshot, support for a variety of back-end storage systems, disk, tape, and even optical, and even connections into the cloud where the backup data can be stored. TSM, as most of you probably know, is a very field-proven product. It has over 20 years experience protecting some of the world's largest data centers and over 20,000 active clients. From an architectural point of view, Spectrum Protect includes a client-server architecture as shown in this picture here. So the clients, which can run on desktops, on database server, on virtual machine hypervisors, or within virtual machines. So the backup client essentially selects the data and backs it up by sending it to the backup server. The backup server, shown in the middle part here, catalogs the backup data, assigns appropriate retention policies, retention periods, and stuff like that, stores the data in the backend storage. Spectrum Protect server uses an internal database, which is a DB2, but it's wrapped by the TSM code essentially to store all the metadata. And another proportion of the storage, or the storage pools, is shown on the bottom of the picture. And the storage pools can be on a variety of storage media. It can be in flash, disk, NAS, optical, even in the cloud. TSM also includes capabilities to tier storage, so you can store backup data initially on disk and then migrate it later onto tape. That is all transparent for the backup client. And Spectrum Protect provides embedded tools for central management, monitoring, and reporting, what you know as the Operation Center. The other component required for the solution is Spectrum Scale. Spectrum Scale is also part of the Spectrum storage family and is a high-performance, highly scalable file system. And not only file system, it can also store objects. So Spectrum Scale is a scale-out file system with comprehensive storage services. It provides a global namespace with unified file and object storage. So global namespace essentially means that wherever you store the data in the upper layer of that picture through GPFS or via NFS or SMB CIFS or HDFS, which is the Hadoop file system, or even via object, wherever you store the data, you can see it from all the nodes, okay? So you see your namespace everywhere where you have a cluster node, essentially. Spectrum Scale has an intuitive graphical user interface for administration and monitoring. Internally, Spectrum Scale provides a lot of value-adding functions. For example, functions for the data lifecycle management. So Spectrum Scale allows to use all kinds of different storage technologies like flash, disk, tape, storage servers, or even a connection into the cloud, which is soon to come. This storage tiering functionality in Spectrum Scale is transparent, so you can, and automated of course, so you can define policies essentially internally where you store certain data on flash where you need fast access to. After this data has been accessed for a while, you can migrate it automatically to disk, so you create more storage space on flash by moving data onto disk. And if the data has aged on disk, you can migrate it further onto tape or onto the cloud and so on. In addition, Spectrum Scale has capabilities to encrypt data and compress data. And another functionality in Spectrum Scale is enablement of global collaborations. So you can access the data anytime, anywhere, for example, through the active file management function, which is kind of a WAN caching function, or even through a remote cluster mount where you can pair different clusters in different sites. Spectrum Scale also has built-in data protection, synchronous or asynchronous replication. It has an integrated backup function, also leveraging Spectrum Protect, but this is not the solution we are talking about here. And it provides also, in a certain configuration, I will highlight later on, it provides a native RAID, which is a software-defined RAID functionality. Scale has unmatched scalability. It can scale to thousands of cluster nodes. I think the largest cluster we know has more than 5,000 cluster nodes. And of course, it can scale throughput. The 400 gigabytes per second is also a real cluster throughput measured by an IBM client within a Spectrum Scale cluster. Of course, not all the functions highlighted here are really relevant for the integration with Spectrum Protect, because Spectrum Protect also offers similar functions, like I mentioned before. For example, tiering. Spectrum Protect also supports compression and encryption and stuff like that. Okay, so if Spectrum Protect supports these functions, we will not leverage it from Spectrum Scale, because it's better to have these functions controlled by Spectrum Protect, because Spectrum Protect is much closer to the data and has much more information about the context of this data. Architecturally, the Spectrum Scale cluster consists of NSD servers, shown in the middle part of the picture. And these NSD servers essentially connect to storage, which can be disk, flash, storage, whatever, and provide this storage as file systems to the NSD clients. The NSD clients architecturally are optional. You don't necessarily need NSD clients on top of NSD servers. From a topology point of view, NSD clients are connected via TCP/IP or InfiniBand to the NSD servers, while the NSD servers can connect via a storage network like a SAN to the storage boxes. The clients can access all the data which is stored on the storage by the NSD servers, so the clients can see all the file systems, can globally collaborate on the data. Applications is shown on the right-hand side, can run applications like Spectrum Protect, for example, can run on NSD servers or NSD clients. And as I said, later on I will elaborate on these architectural options again. Since I have introduced Spectrum Protect, comprehensive backup suite, and Spectrum Scale, a scale-out file system, I would like to present you the integration of these two products. So the integration looks like this. As you see in the picture, multiple Spectrum Protect instances store their database in the storage pools in a Spectrum Scale file system. So Spectrum Scale in this context provides a shared file system, or provides shared file systems to the Spectrum Protect servers. All Spectrum Protect servers share all file system resources. And these file system resources are created from the underlying storage, which can be any kind of technology, right? I mean, in many cases, we have faster storage for the database, more scaling storage for the storage pools, right? Spectrum Scale can accommodate both of that. The Spectrum Protect instances run on the cluster nodes, and they can access the file system or the disk directly. That is one of the key advantages of Spectrum Scale, that an instance running on a Spectrum Scale node actually talks to the disk directly without going through the file system, if you will. And that is an important difference in network-attached storage like NFS or CIFS. I will elaborate on that later on again. The Spectrum Scale file system, which is accessed by all TSM or all Spectrum Protect instances, balances the workload for all instances. So if one instance needs more disk speed and another one needs less, the one needing more can get it, right? Because it's all balanced over all the TSM instances. This architecture essentially provides a standardized, scalable, and easy-to-use storage infrastructure for multiple Spectrum Protect instances. Now, to elaborate a little bit on that, let's look at this next slide, let's say, standard classical architecture with Spectrum Protect not using Spectrum Scale. So in a classical infrastructure, each backup server, each TSM server has its dedicated LANs. These LANs may come from the same storage system, but still they are dedicated to each server. Each server also internally has its dedicated file system. This dedicated file system consumes the dedicated LANs. So from a conceptual perspective, it's creating, for multiple Spectrum Protect instances, it is creating storage islands. Here we have two islands. If, for example, one Spectrum Protect instance requires less storage capacity and one requires more, then it needs to be managed, right? So in the first case, you end up with underutilized storage because the instance doesn't need as much storage as it has. In the second case, the instance which needs more storage needs to get more storage provisioned. So capacity and performance management is more challenging because it needs to be managed within islands. Okay, so each island gets its LANs, its disk, providing capacity and performance. Also, you want to scale the performance or the capacity for TSM instance. It may require downtime for the TSM instance in order to add this capacity to the underlying file system. The Spectrum Scale, that is all different because the backup servers, the Spectrum Protect servers, share all LANs within the file systems. Okay, so shown in the picture here, we have our storage underneath, we have LANs here, and these LANs are all shared by all TSM, by all Spectrum Protect servers. So scaling capacity and performance is seamless and transparent to Spectrum Protect because it happens under the cover of the Spectrum Protect instances within Spectrum Scale. So when you add capacity, you add disk, you make it available in Spectrum Scale, in the appropriate Spectrum Scale file system, and all instances can immediately benefit from that without downtime. Another aspect with this standard-based approach for provisioning storage for Spectrum Protect is that the file system replication mechanism in Spectrum Scale is standardized across platforms. Okay, so whatever platforms you use, there's a standardized way to do file system level replication, and that is the GPFS kind of replication. And of course, this solution provides you a central administration of the entire storage for all Spectrum Protect instances. Into an NFS kind of scenario, because NFS is a network file system protocol, allows to remotely mount a file server essentially. With the network file system, there is a bottleneck. There's a significant performance bottleneck for Spectrum Protect, and that is shown on the left-hand side. The Spectrum Protect server shown here in this picture performs I/O on a single file. It is always bound to a single NFS node. So even though we have multiple NFS nodes presenting a scale-out NAS system, I/O on a single file is always bound to one node, which really creates a performance bottleneck for Spectrum Protect because Spectrum Protect works with single files which are large, right? We call these the storage pool volumes. TSM cannot at all benefit from scale-out NAS systems. That is different with Spectrum Scale because when Spectrum Protect runs in a Spectrum Scale cluster, any Spectrum Protect instance can perform I/O to all disks in parallel. The file essentially is striped across all the disks, and when the file is being read, it's read from all disks in parallel. So there's no singularity in I/O with Spectrum Scale because the Spectrum Protect instance can access all disks in parallel through the Spectrum Scale file system. And that makes Spectrum Scale much more scalable than classical LAN-based or NAS-based storage architectures. So to summarize the key advantages of the solution Spectrum Protect with Spectrum Scale, they have a better storage utilization because multiple Spectrum Protect servers share the same storage. And if one is underutilized and another one is overutilized, it's balancing. It's being balanced within the file system. We have better operational efficiency with one storage platform for all Spectrum Protect servers. So you manage your storage through Spectrum Scale for all Spectrum Protect servers. And all Spectrum Protect servers can immediately benefit from more disks, better networks, and so on. We have a seamless scalability of storage capacity and performance, which means you can add storage to the cluster, and the Spectrum Protect instances can immediately take a benefit from that without downtime. You can add more Spectrum Protect instances to the same cluster in the same way. It's transparent to the others. Spectrum Protect can benefit from the highly scalable performance of Spectrum Scale, which really is realized through a parallel striping across all disks. So we don't have performance bottleneck in here, and we can scale that. If we have performance, if we run into the performance limits, we can add more disk, right? For example, if the network is still sufficient. If not, we only have to add another network. With this solution, we have flexible options for disaster protection. I will elaborate on this a little bit more later on when we talk about the configuration options, but we can use synchronous replication, we can use asynchronous replication, or we can leverage the native RAID functionality in Spectrum Scale Elastic Storage Server. And the solution is cost efficient because it is software defined, existing infrastructure components can be utilized. Spectrum Protect with Spectrum Scale can also run in virtual environments, even have a better utilization of the resources and save more cost with that. And last but not least, Spectrum Scale has a very good high availability characteristic, and Spectrum Protect can ultimately benefit from that. Now let's turn to the configuration options. There's a choice of topology, how to integrate Spectrum Protect with Spectrum Scale. So on the left-hand side, this is the most simple, most basic, and least costly approach to have the Spectrum Protect instances running on the Spectrum Scale NSD servers. Okay, so we don't have Spectrum Scale clients in the picture here. It's a very simple architecture if we compare it to the other two pictures here. So the Spectrum Protect instances here run on the NSD servers and have direct storage access through the SAN. It, of course, requires less infrastructure, and it is typically used when the Spectrum Scale cluster is just dedicated for the use with Spectrum Protect. And the example here with 2 nodes is just an example. We can have much more nodes with Spectrum Scale, Spectrum Protect running. So the picture in the middle and the picture on the right are, from a topology perspective, they are similar, or it's the same topology. It's a client-server topology, as we call it. You have the Spectrum Protect server running on NSD clients that are connected through an IP network or InfiniBand network to the NSD servers. And the NSD servers are connected to the storage through a storage network in the middle picture. And the deployment option with the Elastic Storage Server is pre-configured Spectrum Scale system, which essentially incorporates NSD servers and storage. But when used with Spectrum Protect, topology is the client-server topology because the Spectrum Protect instances run on NSD clients, and they access the ESS or the standard NSD server in the middle picture through an IP network, through an Ethernet network, or through InfiniBand. Well, conceptually, as you can see, it requires a little bit more infrastructure than the NSD server deployment option on the left-hand side. It also has advantages. I mean, you can, for example, create a Spectrum Scale cluster which is used for different purposes, right? So it can be used one portion of the cluster, and you can really partition the cluster in this way. One portion of the cluster can be used for Spectrum Protect. Another portion of the cluster could be used for file storage through NFS or SMB, and yet another one could be used for object storage, right? Using the object storage functionality in Spectrum Scale. So these are the deployment options. In many cases I have been involved. Historically, we see deployment option on NSD server. Okay, so many installations I know and I have sized and configured are with Spectrum Protect running on the NSD servers, which is the picture on the left-hand side. So I also, for simplicity, I will use this picture later on when I explain different concepts. But just keep in mind, it is not limited to run on NSD servers. TSM or Spectrum Protect can also run on NSD clients. And of course with ESS. From an ESS perspective, we see increasing demand to have configurations with multiple Spectrum Protect servers leveraging an ESS as storage. So ESS, Elastic Storage Server, is a prepackaged spectrum scale system. It also comes with a graphical user interface, which allows to monitor the hardware, for example, and of course also the software, the file systems, and so on. It comes with free maintenance and support, and it leverages Spectrum Scale Rate, which is a software function within Spectrum Scale. And Spectrum Scale Rate makes this system-based rate obsolete. So with Spectrum Scale Rate, we use just normal disk attached via SAS chains to the NSD server of the ESS system. Spectrum Scale Rate provides predictable performance for certain workloads, faster rebuild times because of the wide distribution of data. It also provides lower impact during the rebuild compared to traditional RAID systems based on controllers. And it provides 2 or 3 fault tolerance, can be configured depending on the type of data and the protection requirements of the data. Of course, a 3-fault tolerance is more reliable than a 2-fault tolerance. It can tolerate 3 disk failures, right? That is what these numbers mean. And another key function of Spectrum Scale Rate is the end-to-end checksumming. So from a conceptual perspective, referring to the picture on the right, we have our ESS box here, which comprises NSD servers. It has 2 NSD nodes running the native RAID software or the Spectrum Scale Rate software. And attached to these nodes are disks via SAS chains, right? So these are just normal disks. There's no disk controller. The disk controller really runs in Spectrum Scale. And this box provides the global namespace for 1 or more file systems to the Spectrum Scale clients. And these Spectrum Scale clients can all be Spectrum Protect instances. And end-to-end checksum means that when a Spectrum Protect instance stores data in ESS, it will attach a checksum to each block of data being stored. Okay, and that checksum can be validated to see if the data which has been stored is still has retained integrity or not. And if not, of course, the rebuild will start, and so on. As mentioned, ESS is prepackaged. We offer different models for that. There are small models with characteristic of being small from a capacity perspective and fast from a performance perspective. Some of these models leverage SSD drives. Some of them leverage 10K SAS drives. And then we have the large models. They address larger capacities, and they are more scalable from a capacity and performance perspective, leveraging many disk drives. Now in the next slide, I'd like to introduce the synchronous replication with Spectrum Scale, considering a classical Spectrum Scale deployment on the left-hand side and a deployment with ESS on the right-hand side. Okay, so referring to the picture on the left-hand side, where Spectrum Protect runs on NSD servers, if you leverage synchronous replication, of course it's kind of a HADR setup, not Spectrum Protect HADR, I mean conceptually HADR, where we have perhaps 2 sites. We have TSM instances running on both sides, and we have storage on both sides. Spectrum Scale can be configured that all data stored in the file systems are stored on both storage boxes. Okay, so whenever TSM writes data or metadata, it stores in both storage boxes. And the good thing here is, with this deployment on NSD servers, TSM can leverage the SAN capabilities to mirror the data. And SAN really is characterized by high speed and low latency compared to TCP/IP. On the left-hand side, we have the TSM servers running on both sides. If one side fails, we can have an easy restart of the TSM instances on the other side, because the file system is available, or the file systems are available on both sides. So restarting a TSM instance which failed on the left-hand side is very simple on the right-hand side. It's just starting the TSM instance. You don't have to worry about LAN reservation and importing volume groups, mounting file systems, and stuff like that. All that is there. The Spectrum Scale file system is across both sites and is available for all TSM instances. The same essentially happens with the picture on the right-hand side, where Spectrum Protect uses ESS as storage. So we have Spectrum Protect instances running on the left-hand side, we have Spectrum Protect instances running on the right-hand side. We have two ESS systems, or Spectrum Scale is configured to replicate all data blocks on both storage systems from both sites. Okay. The only difference here with the other deployment option is that the replication goes through the LAN, because it's the classical client-server Spectrum Scale architecture, and it uses LAN or InfiniBand between the NSD clients where the TSM instances run and the Spectrum Scale servers provided by the ESS system. Okay, this is the most significant difference between these two deployment options when it comes to synchronous replication. And in both architectures, we have one cluster across both sites. The Spectrum Protect instances can be active on both sides. Of course, one instance is only active on one side, right? Only if it fails, it can be moved over to the other side. From an experience perspective, the reason I really included this slide in this picture here is in various engagements I have been involved, we eventually decided for the left architecture running Spectrum Protect on NSD servers, because the client had a very good SAN infrastructure between his two data centers, whereas the LAN infrastructure was not as good. The LAN infrastructure shown on the right-hand picture between the two data centers really needs to have low latency and high bandwidth. And it's typically a dedicated VLAN, and it's probably going to be 10 or 40 gigabit Ethernet. InfiniBand is most likely not appropriate because of the distances when we talk about a two-site solution. There are replication options for the solution with Spectrum Protect on Spectrum Scale. So we have two replication options. One is the synchronous replication, leveraging the Spectrum Scale functionality. So as shown before, we have one cluster stretched across two sites. We have storage on both sides. We have TSM instances running on both sides, and each TSM instances, or each Spectrum Scale node, essentially mirrors the data to both storage systems. So if one complete site fails, and provided I have an additional quorum node somewhere, the second site keeps on running. It has all the file systems mounted, and it's very easy to restore the TSM instances. And traditional high availability tools like PowerHA on ARX can be used to automate that. So this is a synchronous replication on the left-hand side. We have one cluster with active instances on both sides. And this solution is primarily made for high availability because it really addresses the fact that one data center fails and the operation continues to run on the second data center. Disaster protection perspective, it has one disadvantage, and that is the cluster. So if your entire cluster has a problem, which of course never happens, but when we talk about DR, we talk about things which never happen, right? So if your Spectrum Scale cluster has a problem, then both sides will not be operational, okay? And therefore, I categorize this solution to be more of to address really high availability aspects. Better disaster protection is provided by the Scale Spectrum Protect node replication shown on the right-hand side. We have our TSM instances running in one cluster on the left-hand side and in another cluster on the right-hand side. Each one is a separate cluster, and the replication is really done by the TSM instances from the left side to the right side and from the right side to the left side. And that is based on the Spectrum Protect node replication. Spectrum Protect node replication is asynchronous. It goes through the LAN. The LAN doesn't have to be like low latency, high bandwidth. It really depends on how much data needs to be replicated in a certain amount of time. So the LAN requirements are not as stringent as with Spectrum Scale replication on the left-hand side. We have two independent clusters in two sites, both running Spectrum Protect instances. All Spectrum Protect instances may replicate all or subset of nodes to the other side. And this solution is clearly made for disaster recovery, for disaster protection, because here, if a cluster fails, really, the other one is not affected of that. But it requires perhaps some manual intervention to bring the remaining cluster or the remaining TSM instances in a full operational mode, allowing to back up and retrieve and restore data. Another interesting feature we have with this integration, Spectrum Scale supports LAN-free backup with Spectrum Protect. Now let me explain that. So as shown in the picture here, we have a storage network and we have two nodes. One node is running the Spectrum Protect instances. It's configured on an NSD server. Another node, which is part of the cluster, runs the Spectrum Protect backup client with the storage agent. Important for the LAN-free backup is that this backup client has direct storage access to the Spectrum Scale storage. So the way it works is when the backup client here wants to back up data, in the first step it sends a request to the TSM server to provide a volume, which is a file in the GPFS file system. The TSM server allocates the volume in the GPFS file system and provides the volume ID, essentially the file name, to the backup client running the storage agent. And then the storage agent, because it has direct storage access, it performs the backup directly to the storage without going through the Spectrum Protect server. And for that reason, it's LAN-free, because it's not using the LAN, it goes directly through the storage network to the storage. And if the storage network, in this case, is SAN, the backup is LAN-free. Conceptually, the same process is possible with an ESS deployment, so with Elastic Storage Server, but because the TSM server and the storage agent will not run on NSD servers, but run on NSD clients connected via LAN or InfiniBand to the ESS, it is not a LAN-free backup because they have to use LAN or InfiniBand, right? But we call it a server-free backup because you can do the same thing with ESS, not using in a server-free manner, because the storage agent will not send the backup data to the TSM server, which stores it in ESS, but it will store the data directly in ESS, if you will. LAN-based, but server-free. So LAN-free backup is not possible with the new container pools. So you can only use the traditional file pools for LAN-free backup. It's a summary of the advantages. This solution has better operational efficiency. We have a single point of management, so the storage resource for all TSM instances or all Spectrum Protect instances are centrally managed. It's always on because adding capacity, upgrading stuff is concurrent for the most part to the Spectrum Protect servers. And Spectrum Scale can also be designed very resilient. And it has transparent resource balancing. Balancing of resources, available disk and network resources, is done within the Spectrum Scale file system. And each Spectrum Protect instance can benefit from that. The next benefit is lower cost. Unlike some other solutions using NAS storage, like a scale-out NAS system, this solution doesn't require extra storage for the database. The NAS storage, I think it's not recommended to put the Spectrum Protect database on a NAS share. So if you go with a NAS storage, you need an additional storage box for the database, right? So all Spectrum Protect instances store their database and their storage pools in the same set of file systems. We have a better storage utilization, as mentioned before, because all instances store data in the same file system. An instance needing more space can allocate this, and instance which needs less just doesn't use more, right? And another aspect for lower cost is the solution can be established with standard infrastructure, which can also be reused infrastructure. Another benefit is the scaling parallel performance. The Spectrum Protect instances have direct access to the disk managed by Spectrum Scale. There is no overhead for conversion of files to blocks because the protocol used within the spectrum scale, file system is block-based, okay? So it's there's no overhead for protocol conversion. Unlike a NAS system typically has to convert the NAS protocol into a local file system protocol before it's being converted into a block protocol. All TSM instances can use all available disks in parallel, so to really scale out the performance. And there's no performance bottleneck like in a NAS system where the I/O for a single volume is bound to a single server. With Spectrum Scale, the TSM instances can access all disks in parallel. Also with Spectrum Scale, we allow workload-specific configurations for TSMs, or Spectrum Protect has a database as storage pools. Both entities have different workload characteristics, and when we create a solution, we can take this into account and configure the storage for the database to accommodate the workload for the database. And we can configure the storage for the storage pools to accommodate this particular workload characteristics. So there's much more flexibility with Spectrum Scale compared to other systems. And Spectrum Scale has efficient caching internally for data and metadata. Alrighty, so last but not least, I would like to summarize the integration of Spectrum Protect with Spectrum Scale. We have a global namespace which can be used to create high available clusters across locations. We have flexibility in regard to synchronous replication and asynchronous replication across sites. We have better cost efficiency, as shown before, better performance, and ease of use because of the centralized management of the storage for all Spectrum Protect instances. Turning back to Trisha to see if you have any questions.
Great, thank you so much, Niels. We do have two questions. The first question is, in the instance where the scale cluster is across two sites, is it recommended the customer use HADR for Protect?
I would say no, because you're still limited by the cluster itself, right? So if your cluster goes down, HADR from Protect doesn't help you because the file systems are not available. So I would see HADR as an option where you have two clusters in two sites, right? So you have one cluster primary and one cluster standby, and then you do HADR from the primary cluster to the standby cluster.
And the second question is Spectrum Archive, LTFS, also supported under Spectrum Scale with S.P? So having tape being a tape tier under GPFS rather than connected to the TSM server only?
I mean, this is not supported, and I think it's not needed really because TSM has the same capabilities, right? And the capabilities of TSM are really on an object level, on a backup object level, while the capabilities of Spectrum Archive would be on a file volume level. I think the capabilities we have with the Spectrum Protect are there, so we don't really need Spectrum Archive for that. And also Spectrum Archive, I mean, this configuration is not supported by Spectrum Protect.
Okay, and the third question is Edison a public reference case? No, Edison is a consulting group, and they have, I skipped the slide, and sorry about that, but you can download it later on. Edison is a consulting group, and they have created a white paper comparing performance tests, which IBM has done with Spectrum Protect and Spectrum Scale, and EMC has done with Spectrum Protect and EMC Isolon. And the result of that was, or their conclusion is that Spectrum Scale is up to 11 times faster than EMC Isolon. So the question is, these benefits, can you expand? You had a benefit of better cost efficiency, and so the question is, better cost efficiency compared to what product or what specifically?
Okay, well, better cost efficiency compared to classical deployments. So the classical deployment is where you have these storage islands, right, where each TSM instance has its dedicated LANs, its dedicated file system, and so on. So there's much more operations involved to operate these storage islands compared to operate it with Spectrum Scale. And so Spectrum Scale is more cost efficient from that perspective.